This video is a quick review of solving linear equations. Let's quickly review the steps before we get started. So the first thing you're going to want to do is simplify and combine like terms that happen to be on the same side of the equal sign. So everything on the left that you can do and put together you should, everything on the right of the equal sign you should do if you can. This step can be sometimes non-existent and other times can be a lot of work. It just depends on the equation. Once you've got everything simplified and put together that you can on each side, we're going to start moving things from one side to the equal sign to the other. The first way that you move is always with adding and subtracting, because remember we're going backwards from order of operations, so we would go in reverse. And once you've done all the adding and subtracting to move things around, again, the goal is to get the variable on one side and things without a variable or the constant on the other. And then we're going to multiply or divide to get the variable by itself if we need to. Let's look at some examples. In example 1, I'm looking to see if there's anything on the left side of the equal sign that we could simplify or put together. Well, I have this 12x and this 7, but those are not like terms. I can only put x's with other x's and regular numbers with regular numbers. So I can't put those together. And over here, I have this similar situation where I have an x guy and a number guy, which means I can't do step 1 here. There's nothing to be done. It is simplified as much as we can on each side. So we're going to move on to step 2. We're going to start moving things by adding and subtracting. So the goal here is to get all the things with x's on one side and everybody that doesn't have an x on the other side. Now when I'm saying the sides, we understand hopefully what I mean is on each side of this. So we're going to put all the x's on one side and all the numbers on the other that don't have an x. So the first thing when I look at this and I see these x's here, I've got this x here and I've got this x here, and those are on different sides, so we're going to try and combine those to the same side. So I'm going to take that negative 2x and move him over. Now since he's a negative 2x, we have to do the opposite of a minus 2x, which would be a plus 2x. So I'm going to do plus 2x, but what you do to one side, you have to do to the other to keep this balanced. Then we can combine anything that's like terms. So over on this side, I now have a 12x and a 2x that are like terms, so we can put those together and make 14x. Now this 7 has not been touched, so he's still hanging out. But here's the cool part on the other side. Negative 2x plus 2x is 0 x's. If I have 0 x's, I don't have to write it anymore. They're gone. Now over here, I still have that 7 hanging out. Okay, so we've done part of this. We've gotten all the x's on the left. So now anybody that doesn't have an x, which would be this 7 and this 7, need to be on the other side. Well, he's already over here, but this guy is now in the wrong spot, so we're going to move him. He's a plus 7, so in order to move him, I would minus the 7. Because remember, we want it to cancel out on this side. We want this right here to disappear so that just the x's are over here. And so if I have plus 7 minus 7, that means they're going to cancel. On the left side, we're going to be left with 14x. Now this is kind of weird over here. I've got 7 minus 7. It kind of canceled out over here too, but I've got to put something on this side. I can't just put nothing, but what's the number for nothing? That would be your 0. So if everybody cancels out, you can always put a 0. Usually we don't need it, but in this case, we got to have something over here. We can't just have nothing. Last, we are going to get x by itself by using multiplication and division. Right now, this x has a 14 attached to him. This means 14 times x. So we need to move the 14 away from the x to the other side. Since it's being multiplied, we move it by doing the opposite of multiply, which is divide. So I'm going to divide both sides by 14. And the reason that works is over here, we now have 14 divided by 14 with that x. 14 divided by 14 is just 1. And so now I don't have 14x, I only have 1x. And typically in math, we don't write 1x, we just write x. That means we have 1x. It's not wrong if you put the 1, but it's more polite to just write x. On the other side, I now have 0 divided by 14. Well, 0 divided by anything is 0. So in this case, x is equal to 0. Now, if you wanted to, and you had extra time on a test or quiz, you could check this. You would rewrite your initial equation, 12x plus 7 equals negative 2x plus 7. And everywhere that you see an x, you're going to put in what you're saying x is. So in our case, we're saying x is 0. So we would put in 0. Everywhere you see an x. And then you're going to take each side and combine like terms. Now make sure you follow order of operations still. So we would do 0 and 12 first. So that's going to be 0. Over here I would do the multiply first as well. So negative 2 times 0. And then we can do our add, 0 plus 7. And that's how we know this thing is the correct answer. Now this bit over here that I just did, this is called the check. It is not required, but if you have extra time and want to check something, you can. This right here is our answer. We're looking for what is x, and in this case, x is 0. Let's try example 2. Step 1, simplify and combine like terms on the same side of the equal sign when you can. Well, we've got some work to do here. First of all, I've got some grouping symbols, so I'm going to have to take care of this. And we've got some things we can put together on each side. Now we have to follow order of operations. And order of operations says do grouping symbols first. But we can't do this. 2x minus 3 is not, they're not like terms. We can't possibly put them together. But you probably remember something called the distributive property, and we can do that. Do you remember doing that before? That means we're going to take this 4 times 2x and 4 times that negative 3 to get rid of those parentheses. We'd prefer to just follow order of operations and do a 2x minus 3, but those aren't like terms, so we can't. So the distributive property is a workaround. Now, other than putting those guys together, this bit right here, I'm going to do this first, and I'm going to leave everybody else alone, just like you would if you were simplifying with order of operations. So I'm still going to have this 8, and when I distribute the 4, I'm going to do 4 times 2x, so get 8x, minus, and 4 times 3 is 12. Now, I didn't do anything on the other side yet. Okay. I still have some work to do for step 1. On this side, I see some like terms that we can put together. I have a regular 8 and this 12. Now be careful, this 12 is a negative or a minus 12, so don't lose that sign. So we can put those together. And then on this side over here, I've got this 5 and this minus 3 or negative 3 that are like terms. Because they're on the same side, we can just smush them together. The only time you have to do the opposite to move them is when they're crossing over this equal sign. Because these guys are on the same side, we don't have to worry about doing the opposite. We can just put them together. So if I put together this 8 and negative 12, I would have negative 4. And over here, if I put together the 5 and negative 3, that would give me 2. So now at this point, I have taken everything that's on the left side that are like terms and smushed them together. These two are not like terms, so I can't put them together. On the right side over here, I've put together everything I can. And so we're now done with step 1, and we're moving on to step 2. Step 2, we are going to use adding and subtracting to get all the x's on one side and all the things without x's or the constants on the other side. So first things first, let's look at these x's. I have an 8x on the left and a negative x on the right. I'm going to move that negative x over. Since he's a minus x, we are going to add him to the other side, because remember, you got to do the opposite. And the reason we're doing the opposite is because on this bit over here, on this side, we want it to go away. If you have negative x plus x, that means you have no more x's. So those are gone. Let's look at what we've got on the left now. I've got negative 4. These guys here, this 8x and this x, are like terms, so we can put those together. Remember, that's like a 1 sitting here. So this is 9x. And on the other side, we're just going to have a 2. Next thing, I've got all the x's, let's see, on the left, so I should put all the numbers on the right. So I've got to move this 4. He's in the wrong spot. Now he's a minus or a negative 4, so we do the opposite of that, or add 4, to move him over. And so now these are going to cancel, and I'm going to have 9x equals 2 plus 4, or 6. We're getting close. Last step, we're going to use multiplying and dividing to get x by itself. Right now, this is 9 times x. So to move that 9 to the other side, we're going to do the opposite of times. So we're going to divide by 9. So these 9s are going to cancel because 9 divided by 9 is 1. And so we really just have 1x, or just x. And then everybody panics a little on the other side. This is 6 divided by 9. Now, if you stick that in your calculator, it's going to give you some nasty decimal, and we don't want that. We'd rather have an exact answer. So what we're going to do is we're just going to leave it as 6 over 9. There's nothing wrong with having fractions as answers, and 6 divided by 9 is the same thing as 6 over 9. Now, there's one catch. I bet you know why we can't leave 6 over 9 as an answer. For the same reason you couldn't leave 2/4 as an answer. That's not reduced. So we need to reduce this fraction. Now, if you have a scientific calculator, it will probably reduce fractions for you. If you don't know how to do that, we can Google that or let me know and I can help you figure it out. But what we're going to do is just divide the top and the bottom by a common factor of 3 to reduce. But again, you can do it on your calculator. If you don't like doing it by hand, but you should definitely always reduce. Always, always, always. If you had time and wanted to check this, you could put 2/3 back in everywhere that you see an x, and this side should come out to be the same as that side. This one's a little bit harder to check because it's a nasty fraction. It might be easier when you plug it back in to just put it in as a decimal, or, you know, like a couple decimal places and just round a little, and you'd get really close and then you'd know you had it checked correctly. But you could also check it with this 2/3. Let's try one more. This one's got a lot going on. This left side has a whole bunch of stuff to work with, so we need to simplify and combine like terms for sure. So the first thing I'm going to do is deal with these parentheses. So remember, x and -1 we can't put together, but we can use that distributive property to get rid of those parentheses. So everything else is going to stay put, but I'm going to go ahead and distribute my 4. So 4 times x, and 4 times the -1, and then everybody else is just going to stay put for this round. Now I'm looking to combine some things. Now remember, if they're on the same side, we don't have to do the opposite. We can just stick them together. So on the left side, I see that we have a 4x and a 2x, so we can put those together. 4x plus 2x is 6x. Also on the left side, I see I've got a 6 and a -4, or a -4, and we put those together and I get +2, or +2. Let's look at the other side. Things we could put together. Well, this 5 doesn't have an x, and -3 does not have an x. So those are things we could put together. 5 minus 3 is 2, and then plus 6x. Now, I don't think I can put anything else together because this side I've got an x and a constant. Here I've got a constant and a variable, so those aren't like terms. We can't put them together. Time to start moving things around. So we're going to put all of the x's on one side. They're kind of the same, so this is going to be weird. Okay, let's see what happens here. Let's take this 6x that's on the right and move him over. Since he's a plus 6x, I would have to minus 6x. We're going to get rid of that. Now here's the weird thing. This guy we know is going to cancel over here. That was the whole plan. But the strange thing is this guy also canceled. Okay, so everybody's canceling out. On the left, I still have a 2, so I don't have to worry about like writing 0 because there's still something there. And on the right, I still have a 2, so something's still there. Now, this is one of those special cases. Does 2 equal 2? The answer to that is yes. So when this happens, when we get something equal to itself, a true statement, we know that all real numbers will work in this equation. All real numbers is our answer for this one. Now, if you get down to this spot and you get something that's not true, let's say we got 3 equals 2. That's never true, and nothing you can do can make it true, and that would be a no solution. But because we got 2 equals 2, and that's always true, that means all real numbers is our answer. What we're saying with this answer is you can put any value in here for x, as long as you put the same one in here and the same one in here, and this will check. You could put 5 in here, 5 in here, 5 in here, and this side would be the same as this side when you simplified them. You could also put negative 27 in here, and negative 27 in here, and negative 27 in here, and this side would be the same as this side. Because all of our variables disappeared, and what we got was a true statement. That means all real numbers. If all the variables disappear and you get a false statement, that's no solution.